Hello, welcome to the Queensland Mathematical Methods Paper 2 2020 Work Solutions using TI-Nspire. Okay, so in this works examples, we'll go through all the questions from this exam paper. Question 11. Recall the first 10 questions were multiple choice questions. So in this first question, we've got a sugar company producing packets of sugar, and it finds that 5% are underweight. We're going to consider a packet containing 20 packets or a batch. Part A of the question was how many packets in the sugar can be expected to be underweight. Well, this is just a binomial distribution with what n equal to 20 and p equal to 0.05. And the expected value of S, the sugar being underweight, is just n times p. So that's just 20 times 0.05, which is 1. So that's the expected number to be underweight. Part B of this question asks us to find the variance of this batch. Well, the formula for the variance is given by NPQ, or NP times 1 minus P. So just substituting in the numbers there, N is 20, P is 0.05, 1 minus P is 0.95. That just gives me 0.95 for the variance. No need to really use a calculator to multiply those numbers together. Part C of this question, determine the probability that at most one of the sugar in the batch is underweight. So what does at most one mean? At most one means S is less than or equal to 1. So that would mean the probability that S is equal to 0 or the probability that S is equal to 1. S equal to 0 for the binomial distribution is what? N above x, p to the x, q to the n minus x. So q is 0.95 to the power of 20, and for the probability S equals 1, it's 20 times 0.05 times 0.95 to the power of 19. Now we can work that out algebraically, or let's go to our calculator. And what do we want to do this time? We want to find the binomial probability. So we go menu, probability, distributions. We want a binomial CDF because we're calculating more than one value. The number of trials is 20. Tab to the probability of success, which is 0.05. The lower bound is 0 and the upper bound is 1. So that gives me the answer there, which is 0.7358, 4 decimal places. Question 12. This time we're given some rates of change in population for two cities. City A is A dashed or dA dt equals 45 over t plus 1, and city B is B dashed as 105 e to the 0.03 t. T is the number of years since 2018 and measured in people per year. The initial population for City A was what, 5,000, and the initial population for City B was 3,500. Determine the population models for both cities. Okay, so these are sort of like differential equations which we have to solve. A dashed or dA dt is 45 over t plus 1. A then is the indefinite integral of 45 over t plus 1 dt. That integral is fairly easy. It's just what? 45 log e t plus 1, and I'll call the first constant of integration there CA. Okay, to find the first constant, we'll use the fact that initially when t equals 0, the population of city A was 5,000. So if we substitute t equal to 0, that gives me 45 log e of 1, which is 0. So therefore CA is 5,000. So A of t for city A is 5,000 plus 45 log e t plus 1. Let's do the same thing for city B. dB dt is 105 e to the 0.03 t. B then will be again the indefinite integral of 105 e to the 0.03 t dt. The integral of e to the kx is 1 over k e to the kx. So B of t is 105 divided by 0.03 e to the 0.03 dt plus CB. Now, how are we going to find CB? Well, the initial population of city B was 3,500, and 105 over 0.03 is 3,500. So therefore, CB, the second constant of integration here, is 0. So the formula for B of t is 3,500 e to the 0.03 t. Okay, so next part of this question, use the information in 12a that we've just discovered to figure out the population of city B at the beginning of 2028. All right, so let's go to our calculator now, and let me define two functions here. So I'm going to go menu, action, define. I'll define f1 of x. Now I'm using x here instead of t. So for city A it was 5,000 plus 45 times log. So we've got control log e is log to the base e of x plus 1. Now I might want to graph these later. So I'm going to say the given command, given that x is greater than or equal to 0. Because if we do a graph, we don't want to see it for negative values of t, or in this case, x. Let's do the same thing for city B. Let's do menu, actions, define. And I'll call this one f2 of x. And this one is what, 3,500 times e to the 0.03 times x. Once again, I should have defined that one to be greater than or equal to 0, because I'm going to sketch the graphs later on. Okay, so for city B, we want to find that in 2010, and that's 10. So really, I just want to find f2 at 10. So the answer there is 4,725. We're going to have to round that one up. So it's 4,725 people. Now, this is where what I've done comes in very useful. Use the information that we've already got to predict when the populations will be the same for both cities. Well, what do we have to do this time? Well, basically we want to solve when the two populations are equal. So let's go menu, algebra, and solving what f1 of x is equal to f2 of x, and we want to solve that for x. So that will give me at 12.66. The question asked for what year? Well, the year then is, this is after 2018, so it's in 2030, the year. Okay, so that's a nice way of solving that. Now, as I said, let's go back to the graphs page and let's have a look at how to solve this one graphically as well. So I've defined the two functions. So let me go to a graphs page now. And if I just press up arrow, there's my first function. Obviously, my window settings are not correct here. So let's go menu, window zoom, window settings. What settings do you think we'd use for x? Well, x was 12, so I'll say -3. I'll go up to say 18 in steps of 3. And the Y scale is in thousands, so I'll say -2,000 up to say 8,000 in steps of 1,000. And there we see the two graphs of the cities. Now they sort of appear like straight lines, but obviously they're not straight lines. Change the colors here to be say red, and for the first city we'll change its color to say blue. Now, what were we doing? We were finding where the cities are equal. Well, to do that, we want to find the points of intersection. So let's go menu, analyze graph, intersection. And sure enough, we've got our answer there as 12.7, which is what we got before. All right, question 13. An online retailer claims that 90% of orders are shipped within 12 hours of being received. On a particular day, 121 orders were shipped and received, and 121 were received, 102 were shipped. So what's the sample proportion of orders shipped within 12 hours? Well, that's fairly easy. It's only 1 mark. P hat here is just 102 over 121, which is 0.843. The value P is 0.9. That's what they claim, 90%. All right, now we've got part B and part C here. The distribution of the sample proportion that are shipped within 12 hours is approximately normal. Assuming the online retailer's claim is true, find the probability in a sample of 121 less than 85% of all orders are shipped. Okay, so what's going on here? Well, what do we know? Well, what's the distribution of the shipping? Distribution of the shipping I've called R here. R is approximately normal with a mean of mu and a variance of sigma squared. The mean, mu equals NP, which is 121 times 0.9. That's the value of P, which is 108.9. And sigma, or the standard deviation, is the square root of NPQ, which is 121 times 0.9 times 0.1, all square rooted, which is 3.3. Okay, so what are we going to do then? Well, we will use this normal distribution to find out the probability that it's what? Less than 85%. Now, what's this? This is what's 85% of 121 is 102.85. So we want the probability of R being normal less than 102. So how did I do that? Okay, so let's do that on a calculator. What I might do here is I might add in a new problem. So we're going to insert a problem so that functions and variables are not known. Okay, so first one was P hat. Let's see if we can actually store that value as P hat. Let's have a look here at the book command. The book command is a catalogue of all the functions defined on the calculator. We've also got some other variables here, such as pi and all those things. Yeah, look, there's a P hat here. Let's have a look at P hat. So I'll say that P hat is assigned equal to 102 over 121. Okay, so we've calculated all those values. What we want to do now is just have a look at what was the distribution now. So menu, probability and statistics, distributions, normal CDF. My lower bound, well, that's a bit excessive. We don't need such a small value. My upper bound is 102.85. My standard deviation, or my mean, was 108.9. And my standard deviation was 3.3. Okay, so that gives me the answer there of 0.0334. Let's evaluate the reasonableness of this online retailer's claim. What do we think of this claim? Well, the probability that we got was 0.0334, which is very small. It's much smaller. So it's very unlikely that the retailer's claim is true. But can we perhaps do this another way? Can we get another result to verify it? So in part B, we used a normal distribution. Can we use a binomial distribution? Yes, let's try a binomial distribution as well. So let's try it using binomial. What's using binomial? Okay, so let's try a binomial distribution here. Menu, probability, distributions. This time I'm going to use a binomial CDF. What's N? N is 121. What's my probability of success? This time I'm using 0.9. What's my lower bound? My lower bound was 0 up to, now this is where it gets interesting. Normally in a binomial CDF, you'd expect that these values here to be integers, but you can type in decimals here. So the upper bound can be 102.85. And again, that answer sort of indicates what we got before, 0.0334 using a normal, and using a binomial, 0.0321. So they are very close. So what I was also saying there is that rather than using 102.85, if I just use 102, then I get the same result there. So the binomial distribution has given me the same answer. Okay, question 14. Let X denote the time in minutes between arrivals of trains at a station. The cumulative distribution, this is the big F value, capital F. Capital F is 2 minus 10 over X for 5 less than X less than 10 and 0 otherwise. What's the probability density function? Well, the probability density function is the derivative of the cumulative distribution function. So we have to differentiate 2 minus 10 over X. The derivative of a constant 2 is 0. The derivative of 10 over X is 10x to the minus 1. So that's just going to give me 10 over X squared. Once again, between 5 and 10 and 0 otherwise. So little f is the probability density function. Big F is the cumulative distribution function. Determine the probability that X is between 5 and 7. Well, a number of ways we could do this. We could just work out the big F between 7 and subtract off the big F at 5, or alternatively, we can integrate up. Well, if you think about it, if we've got 10 over X squared and we're integrating that up, then we're getting 2 minus 10 over X to be evaluated between 7 and 5, which, as I said, is F at 7 minus F at 5, capital F that is. Substitute in the numbers, 2 minus 10 over 7 minus 2 minus 10 over 5. The 2's cancel and we get 4 over 7 as a decimal. How could we do that one? Well, very easy. Let's go to a new document again, insert a new problem, add a calculator page. This time I want to go menu, calculus. I want a numerical integral between what, 5 and 7 of the function 10 over X squared. Now that gives me the decimal. Let's just see if I type in 4 over 7 and press Control Enter. Yes, that's the same value there. Okay, part C of this question asks us to find the mean time between arrivals at the station. Well, what's the mean time? The mean time, the expected value, is just the integral between x times f of x dx between the two values. So once again, we'll just go to our calculator. And if we think about this, then really this is between, what was it, defined between 5 and 10. So I could just press my up arrow a couple of times and edit this to between 10 and, if it's x times it, then it's just 10 over x. And that gives me 6.93. Let's go through that by hand. That's 10 log x between 10 and 5. 10 log 10 minus log 5 is log 2. And once again, that will give me 6.93 minutes. Probably would have been better to define the function f of x as 10 over x squared and just work out all those definitions. Okay, question 15 now. What we got here? We've got a field is divided into 5 sections as shown. The width of each section is 1 metre. Perpendicular height in metres of each section is shown in the diagram there. And that area is approximated by a trapezoidal rule, and it's found to be 11.12 square metres. Okay. So what's the formula for the trapezoidal rule? And obviously we want to find that unknown height there of x. Well, formula for the trapezoidal rule, I think all of these are given to you on the formula sheet. It's h on 2, where h is the width of each of the segments, which is 1. Y naught was the first one, 2 times all the middle ones plus the last one. So we've got this result here, 11.2 equals 0.5 times 1 plus 2 times the middle ones plus the last one. Well, we basically just want to solve that equation. It's fairly easy, but let's use our CAS to solve that one. Once again, I'll just go to a new problem for a start. So what do I want to do? I want to go menu, algebra, solve or NSolve. 11.12 equals 0.5 times, I've got 1 plus 2 times all the middle ones. That was 3 plus 2.6 plus 2.2 plus x, close the brackets, plus the last value 1.76. Come on, I want to solve that for x. So x is 1.94. You can do that one by a bit of algebra as well, just adding up some of the values there and working it out. But once again, we'll get x is 1.94. Determine the area of the field is modeled by the function. Well, this time we know that the curve f of x is 4x over x squared plus 1 for 0 less than x less than 5. And what we want to find is the area of that field. Okay, so we just have to evaluate that definite integral and do a numeric integration. Menu, calculus, numeric integral, 0 up to 5. Let's type in my function now, which was what? 4x over x squared plus 1. We need a plus 1. Notice when I type in the plus 1 now, we've got brackets around all of that. And so my answer is 11.516. Okay, bottles of soft drink now for question 16. There's a lot in these questions now. They're getting a bit more complicated. The first couple of questions were, complex, familiar questions. Now they're becoming a bit more tricky. So bottles of soft drink should contain a volume of 591. So that's the mean, isn't it? Any bottle below the 20th percentile is rejected. Percentile is just given as the percentage of which the observations occur. 35% bottles contain more than 593 mils. We have to determine the smallest volume that will be accepted here. Okay, so what are we given? What do we know? Well, let's let B be the amount of drink in the soft drink bottles. B is a normal distribution. Mean is 591, but the variance is unknown. All right, what are we given here? We're given that 35% contain more than 593 mils. Now remember, when we use inverse normal on our calculator, it has to be a less than. So we're going to have to change that around. Instead of words B greater than 593, we're going to have to say B is smaller than 593, and that's 0.65. Okay, so what do we want to do? Well, we want to get the z-score corresponding to an area of 0.65. So let's go to my CAS calculator, not a CAS calculator. Let's go to a calculator and go menu, probability, distributions. This time I want inverse normal. What's my area? My area is 0.65. And my mean and standard deviation for the standard normal curve are 0 and 1. So that gives me my z-score, which is 0.3853. So the z-score, 0.3853, is equal to what? X minus mu over sigma. Well, the x is 593, the mu is 591, the sigma is what's unknown. So 593 minus 591 is 2 over sigma is 0.3853. So what we've got there is just 2 divided by my last answer. In all of them. So 5.1905, that is my standard deviation or my sigma. So let's just assign that value to S, all the decimal places. Okay, so what's now? That's sort of 2 parts of this question. We want to find now what percentage are rejected. Remember, any bottle less than the 20th percentile was rejected. Okay. So now we know that the bottles are normally distributed with a mean of 591 and a variance of 5.19048 squared, the value just found. Let R be the smallest value for which they're rejected. The probability of B less than R is 0.2 because 20% are rejected. Okay, so we basically want to solve the Z score corresponding to the area of 0.21. Well, that's very similar to what we did up here with the 0.65. I could go through all the menus again, or just easier probably to press up arrow twice and change that 0.65 into 0.2, and that's negative 0.8416. That's my Z score. So Z equals what? X minus mu over sigma. I want to find the X score. So Z equals X minus mu over sigma equals minus 0.8416. So basically, we just want to solve the equation for X. Numeric solve, my X is really R, minus my mu, which is 591, over my S, and that equals that value there. And what do I want to solve that for? I want to solve that for R, sorry. Okay, so R equals 586. But don't think that would be the answer. I think we're going to have to round that one up and say the smallest amount that would be accepted is 587 mils there. So to round that one up to the nearest integer. Okay, question 17 now. In a survey of 326 lecturers, 303 said that on at least one occasion a mobile phone had rung in the lecture. Okay. Determine the sample size to conduct a follow-up survey that provides 95% confidence this 1-point estimate is within plus or minus 0.02 of the population proportion. And what's going on here? Well, this time the p-hat value is 303 over 326. A 95% confidence interval, well, that gives me a Z score of 1.96, and the confidence interval is p hat plus or minus Z times the square root of p hat times 1 minus p hat over n. So everything in that equation there is known except for the value of. So basically, if we substitute in everything there, plus or minus 0.02 really means that Z times p hat times 1 minus p hat over n equals 0.02. So we have to solve that equation for n. And if we solve that equation for n, we'll get 629. Let's just try to perhaps do that one on our CAS as well. I'm going to go to a new problem as well, because I'm going to have a different value of S here. First of all, let's get my Z score. What was my Z value? What was my Z value? It was a 95% confidence interval. Well, for a 95% confidence interval, the total area to the left from the value to the negative value is 0.975. So 0.975, that's my Z score of 1.96. So let me store that value of Z as Z. Once again, let's go to my book command and get my value of P hat. P hat assigned equals, we're storing that value of 303 over 326. And what am I really doing now? Basically, I just want to do a numeric solve of 0.02 equal to the Z score, Z value, times, what was it now? There's a template, and it was, I'll just press var here, it gives it to me straight away, times 1 minus var over n, comma, n. So that's what I'm solving, really, that equation. So n is 629.75. A nice way of solving that equation rather than going through all that sort of arithmetic. Once again, that's probably not the final answer. We have to round that answer up to give the follow-up sample size to be 630. Okay. Couple of little questions left. This time we've got a diagram showing a quadrilateral A, B, C, D. It's a quadrilateral, yeah, it's got 4 sides, 4.1, 7.6, 5.4, but the distance DC is not known. If I want to find the perimeter, I have to add them all up. So I have to find the distance DC. But before I can find the distance DC, it looks like I might have to find the distance BD. All right, so I think we're just going to use cosine rules, aren't we here? Let's just have a look at this one again. Cosine rules, yeah, cosine rules. So in the cosine rule, in the triangle ABD, I want to find the length BD. So BD squared, what's the cosine rule say? It's 4.1 squared plus 7.6 squared minus 2 times 4.1 times 7.6 cos of the included angle there is 117 degrees, and that gives me the 102.86. BD then will be the square root of that, which is 10.142. Let's see a nice little way of doing that one on the calculator. So let's try to do this one. I'm going to say BD2, which is the BD squared, is 4.1 squared plus, what was it, 7.6 squared minus 2 times 4.1 times 7.6 times the cos, get that from the trig menu there, the cos of 117. Now, it looks like my calculator's in the degree mode, but let's be safe and sorry. Let's put a little degree symbol there, and that'll give me the value of BD squared. So if I want the length of BD, I'm going to have to take the square root of that value. Okay. All right, so now we want to find the length BDC given the length BD, which we've just found. So we're going to use the cosine rule again, but this time I'm using the cosine rule in triangle BCD. Okay. The unknown is DC, so I'll call DC equal to X. So this time in my cosine rule, I've got BD squared, which is 10.1421 squared, or 102.86, equals 5.4 squared plus X squared minus 2 times X times 5.4 times the cos of 62 degrees. Okay. So we could solve that again on our calculator to give me X equals 11.4867. Let's just do that. Now, this time, what are we doing? Going menu, algebra, N-solve. Now, think about it, it's BD squared. Well, that is BD2, isn't it? That is what I called BD2. So BD2 equals 5.4 squared plus x squared minus 2 times x times 5.4 times the cos of the included angle, which was 62. Even though we are in degrees, we're going to make sure. And I want to solve that equation for x. Okay, the calculator's given me a negative answer there. Obviously, it's a quadratic. There are two answers. The answer that I want is the positive value. So 11.4867 is the correct answer there. And then the perimeter is simply the sum of all the lengths that we've got. That was 5.4, 4.1, 7.6, and the last answer that I just got. So the perimeter of the figure is 28.587. All right, so now we're getting on to the last two questions here, question 19 and 20, which are sort of complex, unfamiliar type questions, aren't they? This is something we won't see in sort of many textbooks here. So we've got the following information. The length of a curve, y equals f of x, over the interval a to b is the integral from a to b of 1 plus dy dx all squared dx. All right, we're driving along a road with a vertical distance above sea level, given by that function 300 plus log e x squared minus 3x plus e. X is the horizontal distance from an initial point in kilometres at sea level. X is positive if you are east and negative if you are west. So you're starting your drive 10 kilometres west and then you're going 10 kilometres east. Time spent driving downhill we have to find. If we're driving downhill, all right, there's a lot in this question. You really have to sort of read this question and figure out what's going on. Well, this function d of x, sort of, you know, let's have a look at this function d of x. D of x, let's have a look at the value first of all at negative 10. D at negative 10, we just use a calculator to work out that value, it's 304.88. D at 0 is 301, and D at 10 is 304. So it looks like it is going down a little bit and then coming back up a bit. So we could graph it and find the turning point on the graph. Alternatively, let's use our calculator to find out where this function has a turning point. So once again, I'm going to add a new problem here. I'm going to define my function. I'll call it f1 of x. I could graph it, but there's no probably need to. 300 plus log e, that's ln of x squared minus 3x plus e. Number of ways we can get the e. Let's just get it straight from this I button here. All right, so what I did is I just evaluated f1 at minus 10, evaluated f1 at 0, and evaluated f1 at 10. Okay, so where is my turning point going to be here? Well, let's use the calculator to find that. Let's go menu, algebra, numeric solve, but I want to solve where the gradient is equal to 0. All right, let's do it from the template. It's probably easier. Numerically solving f1 of x equals 0 for x, 1.5. So it looks like my turning point occurs when x is equal to 1.5. In other words, what's going on here? Well, we could have done this one by hand. Once again, the derivative of log e x squared minus 3x is just the derivative of that function, which is 2x minus 3 over the function. The derivative of 300 is 0. So if we solve that equal to 0, we get x equals 1.5. In other words, what's going on here is that the gradient function is negative between -10 and 1.5, and it's positive between 1.5 and 10. Okay, so that means you're driving downhill between -10 and 1.5. And then you're going uphill between 1.5 and 10, because that's where my turning point was at 1.5. Okay, so to calculate that distance, we want to say, all right, let's let S, and I'll assign S to equal the integral between what? Between -10 up to 1.5 of 1 plus the square root of that function. So the square root is d by dx of f1 of x. That has to be squared, and we have to evaluate that in that definite interval. So that's the distance for which we're driving downhill, 13.255. Now, the question said, if you're driving downhill at 40 kilometers per hour, find the time. Well, time is just the distance divided by your speed. So let's just say, what is S divided by 40? 0.3314. So at 40 kilometers an hour, the time is just S over V, which is 0.33 hours. Once again, we could have looked at that graph and shown that it had a turning point at 1.5. Sort of verified that. All right, last question in this paper. Once again, we've got this time a normality of two sample proportions, P1 and P2, based on an approximate confidence interval, P1 minus P2 minus Z. Yeah, all right. This sort of looks like the formulas for the one sample, but it's got two samples in these things. So if the approximate confidence interval does not contain 0, then this provides evidence that the two proportions are not equal. All right, so data in the table provides observed frequencies of two drink preferences for independent samples for people who live in town A and town B. So find a 99%, using the 99% confidence interval, if there is evidence to conclude that the drink preference is associated with the town where the person lives. Okay, so what's going on here? Well, let's just have a look at this. For town A, what's happening? For town A, let's just look at T. There are 111 people out of a total of 216, so P1 hat will be 111 over 216. P2 hat will be 150 out of 257 for town B, and 99% is 2.578. N1 and N2 are 216 and 207. All right, so let's try to work out this confidence interval on our calculator and see if it does or does not contain value of 0. Once again, I'll just insert a new problem and add a calculator page. Now, let's just define some variables here. First of all, we just want to check our z-score. What was my z-score? If I want inverse normal okay, probability distributions, inverse normal for a 99%, then I've got 0.01 in both tails combined. So from that value to the left is 0.995. So my z-score, yep, was 2.5758. So let's say z is assigned equal to that value. Okay, P1 for T was 111 over 216. P2 was equal to 150 over 257. N1 was equal to 216, and N2 is equal to 257. So all I really want to do is I want to calculate the formula P1 minus P2 minus Z times, now this is the formula that I'm typing in, it was as a template here, P1 times 1 minus P1 over N1 and plus P2 times 1 minus P2, this was over N2. So that's minus 0.8188. Now to get the other, that's the lower confidence interval, the upper, all I have to do is change that to a plus 0.0483. Right, so it wasn't too bad to work all that out. There's my confidence interval for T. Does that contain 0? Yes, since this interval contains 0, then that gives me insufficient evidence to conclude that there is a preference for drinking tea as associated to where the person lives in the town. Let's have a look at coffee now. So for coffee, well, what's the only difference here? For coffee, P1 is 105 over 216, town A, or P1, and P2 is 107 over 257. All the other values are the same. So let me just have a new value of P1 this time, which is 105 over 216, and a new value of P2, which is 107 over 257, and just pressing up arrow a number of times again to get that formula again. This time the lower value is 0.0483. The upper value, we just got to change the minus Z to a plus Z, is 0.8188. So for this one, the confidence interval is minus 0.048 to 0.188. Does this contain 0? Yes. So since this interval contains 0, once again, there is insufficient evidence to conclude that there is a preference for coffee associated with the town where the person lives. All right, so that was a little bit different. Now, let's just have another little think about what's happening in that question there. This is not something that's really in the course. Let's just have a look though, what's happening here. This is statistics. This is really confidence intervals. What do we know? We really know about a 1 proportion Z interval. This is really a 2 proportion Z interval. All right, so let's just have a look at what's happening here. For the 2 proportion Z interval, what was X1? It was 111 and N1 was 216. Tabbing to the next field was 150, 257. The confidence level was 0.99. And sure enough, that gives me all the values that we just worked out in that confidence interval. That was for T. Let's go through that again and go through statistics, confidence intervals. This is a 2 proportion Z interval. This time I'll do it for coffee in towns, the 2 towns. So this time the P1 was X, which was 105 over N. The X2 was 107 over 257. Once again, let's just change that to 0.99. Yep, the lower value was 0.048 and the upper value was 0.8188. All right, so that's something a little bit different, but not that complicated, and really just substituting into the formula. All right, so that's the end of our 10 questions for Queensland Paper 2 using the TI-Nspire calculator to get most of the answers to these questions. Okay, bye.